Okay, so usually the advice I would give to my student mainly is when you get to having the formula sheets or the formula list, it's good to know, every single lines, what they mean or where you would need them. So if you could print out on your own one of them and then write a few comments next to each of those lines, that might be helpful for you. For example, if you're asked for the roots ax squared plus bx plus c equals 0, then you've got, your quadratic formula here. Then you know the two roots are minus b plus and minus square roots of b squared minus 4ac. The thing that I usually write next to this would be, for example, discriminant b squared minus 4ac and nature of roots. So whenever I'm going to see a question that's asking me for the nature of the roots, I know I've got to calculate that discriminant, okay, whatever is under that square root. Then you do the same for your sine rule. Where would you need that? Your cosine rule. If you've got two lines on a triangle, and for example, the angle between those two, you would need to use the cosine rule. If you're asked to find the area of a triangle, and that means you need to use the area formula here. Okay, so it's for any triangle as well. So if you had a right angle triangle, then the area would just be half of AB. Then you've got the three volumes there, volume of a sphere, cone, and pyramid. And the last one is the standard deviation. What I'll teach you with the standard deviation is the first formula. I find the first formula easier to use, and we see less mistake made with the first formula. Okay, so without further ado, I think now we've got everyone here. So this was the first question. Like I said, I've asked you to go through maybe 5 a day. So at least by today, you should have managed to get right up to question number 30, right? If you've tried at least 5 a day, 5 questions a day, it's a good way to go through them without, making it too much. Okay, so if you're asked to evaluate, for example, mixed fraction like this, 6 1/5 minus 2 1/3, I've seen students go in two ways, okay? And even in this class here, some people would do it in one way, some other would do it another way. The one thing I noticed which made me make much less mistakes, especially when I've got to subtract two mixed fractions, is to change the mixed fraction into top-heavy fractions. So we see much less mistakes being made when it's the case, right? Some people might argue they find the other way much easier, but that's the way I would do it basically. Okay, and if you were to do that, the first thing you would get is 31/5, because you do 5 times 6 plus 1/5. Take away 3 times 2 plus 1, that's 7/3. And once you do that, the other thing that some might say, okay, I need to get the common denominator. If you've got the cross and smile or the kiss and smile method, you can just apply it to this, which gives you 3 times 31 minus 5 times 7 divided by 5 times 3. Okay, so that's how you would do it to get your first marks there. That would give you 93 take away 35/15, which is 58/15. So you might say to me, okay, can I leave it like that? You could, but if we look at the question here, they've started giving us mixed fractions. So what we're going to do is we're just going to give them our answer with mixed fraction. So you would divide 58 by 15, which is 3, and the remainder would be 13. Okay, so that's why the answer that you got on that paper was given as mixed fraction. But if they don't tell us, if I'm marking your paper, if you give me 58/15, I would give you the mark. But if the question is give your answer as a mixed fraction, then you've got to get the last mark with the mixed fraction. Okay? Because I kept telling you guys, if you're not asked to do something, you don't have to do it. Okay, so any question with fractions, you know, or would you like to see the other method, the way you would do the other method?
That's the method I would use. I'm quite happy with that one.
That's what I did.
Yeah, so basically, if you've got a method and it works for you, I would advise to just keep using it. Yeah, so I would tend to go top heavy, cross and smile, and finish that off. And to be honest, if you had leave it to 58/15, you would get all the marks. Okay. That would be my advice. Now, the next one. So we've been given a straight line. Okay, so straight away we know it's a straight line. We've got a point on the line, but we've got another point here. So at first we had what we call that value 8 is what we call the y-intercept. Okay, so it's when x equals 0, basically. When x equals 0, the straight line cuts the y-axis at what we call the y-intercept. So that 8, you've noticed I've rewritten it as 0, 8. Just to remind me, it's x equals 0, y equals 8. The same here, I've got x equals 6, y equals 4. So first thing first, I'm going to try and give a y equal mx plus c equation. So that's the equation of the line. Okay, a standard equation. How do I find m? 2 ways. I can find m using, if you remember, the y2 minus y1 divided by x2 minus x1.
Yeah.
But here, you could see that the y-intercept is given to us already.
C.
It's c, yeah, so c equal 8. So straight away, I've got c equal 8 here. So what I'm going to do with that, I'm going to calculate m, because I've got c, by deciding which one is y2. So usually we go from left to right. You don't have to. If you were to go right to left, it'd be fine. You should get the same answer. So you would go y2 is 4, take away y1, 8. So 4 minus 8 divided by 6 minus 0, x2 minus x1. And 4 minus 8 is negative 4 divided by 6. So now you remember, whenever you're going to have a fraction, even if they don't ask you to give it to its simplest form, you've got to simplify it. And what I always tell my student is, whenever I see 2 even numbers here, I know straight away they're both in the 2 table. Okay, the 2 time table. That means I can divide both numbers by 2, and this time I got minus 2/3. And something tells me that 2 and 3 are both prime numbers. I can't simplify it any further. So I've got m, and I know what c is. Your final answer is given here, y equal negative 2/3x plus 8. Is that big enough, or do you want?
No, that's fine.
I can see it. Yeah.
You can see okay? I wasn't too sure. And that's how you would come up with this answer. Okay?
Yep.
So the one thing to remember here is the standard form, what is the y-intercept, and how to calculate a gradient. So now let's say you can't remember the gradient formula. What you need to do here is, because you would write, for example, let's say I couldn't remember the gradient formula. Okay, so if that was the case, what I would have done is, you see that 6, 4 belongs to the line. What it means is, when x equals 6, y equal 4. So you could write here 4 equal m times 6 plus 8. So basically 4 equals 6m plus 8, and you've got to solve this. Find me what m is. So you just take away 8 on both sides. You just solve this equation. So take away 8 on both sides. Then you end up with -4 equals 6m. And then you divide both sides by 6, and you should get the exact same value. And that means m is -4/6 or -2/3. So this is, imagine you couldn't remember the y2 minus y1 divided by x2 minus x1. This 6, 4 here belongs to the line. So you just substitute x here, sorry, y. This is what we used to call a and b, for example, and you would get m that way. But the good thing about knowing m equal y2 minus y1 divided by x2 minus x1, if you're given, for example, 2 points and they ask you to find the gradient, then you would use that straight away. Okay. So there's always other ways to find solutions. So third question. This time I've got to use indices. So indices rules, we've looked at them. So how would we go about this question? I've got a square times 2a, which is to the power -1.5. So you could just rewrite that as 2a square times a -1/2 plus a square times a, or a to the power 1. It's the same thing. So what I've done is I've just timed this a square here with that first component, and as well a square times a. That's what I've just written there. And the rule of indices tells us that if you've got a square times a to the power -1/2, you just add it 2 to -1/2, which is 2 minus 1/2. And the same here, I've got 2 and 1, that becomes 2 plus 1. So 2 plus 1 is 3. 2 minus 1/2 is just 1/2. Okay. Sorry, it's 1.5, I should say. So you need to be careful. Because you've got 2/1 minus 1/2. So you can do the same as cross and smile. 2 times 2 is 4 minus 1. So 4 minus 1 is 3. 3/2. Okay. So 2 minus 1/2 basically is 1.5. Or you can just rewrite it as 2/1 minus 1/2. And that's your final answer here. 2 to the power a 3/2 plus a cubed.
Is there, can I just say, ask Adrian, I mean, is there any way that, because my first thought is always trying to get rid of a fraction because they're just horrible. You know, I know that the indices rule states that you obviously, when you have two powers, that you, on that scenario, you have to multiply them together. But you know, dealing with fractions, sometimes I would try and try and get them. There's a negative at the top, but that's you can't really do much with that. If there's a -1.5, it's, I don't know. I'm just.
Yeah. So if you would, the problem you have, basically, you could have said, okay, I'm not seeing this much, so how can I change this? The only thing you had here was, because it's -1/2, if you don't like the negative, you would rewrite it as 2a square divided by a/1/2 here.
Okay.
plus a squared times a, which is a cubed. But you still got that half there. So you still got the fraction.
Mhm.
And you know that if you've got
It's
a
active.
at the top, yeah, you need to do 2 minus a half, basically.
Just hate
That-
dealing with fractions.
Yeah, so you still have to finish it off.
Yeah.
That's why fraction is part of National 5. So you will
Yeah.
see question. So you still got to do minus a half here. So you've got to deal with 2 minus a half plus that a cube.
Yeah, just make the two form as a fraction. Yeah.
And if you don't want to do the cross and smile, you've got to kind of think
5/2.
of yeah.
Simplify.
What's 2 take? You've got 2 pizza, you take a half of it. You still end up with 1.5 pizza, for example. Yeah. Okay. Yeah, so you need to be able to manipulate
Yeah.
fractions.
Mhm.
Okay.
It's a negative at the top. That's just is what it is, but you can't really
Yeah,
change that.
you can put it underneath, but you still got to do a 2 minus,
Yeah,
which
still got.
just give you an extra line that's probably not needed.
Mhm.
Okay. So the next one is just to solve an equation. So whenever you're going to see solving an equation, the first thing, I've got to get rid of those brackets. That's the first thing you've got to put in your head. And to get rid of that bracket, I've got a -2 here. I need to time, I didn't say 2, I said -2. Okay, so -2 needs to be time x, and then -2 time -1. So that's the common mistake. People forget to put, it's a -2 time. And then that means you've got x minus 2x, -2 times -1 is +2, and just equal 8. And now I've got x minus 2x. You've got to simplify that. That becomes -x plus 2 equal 8. And now it's easier to solve. Okay. So 2 class here. So you can say I'm going to get rid of 2 by taking away 2 both sides. So if you do that, you end up with -x equal 8 minus 2. And 8 minus 2 is just 6. So -x equals 6. And to get rid of that negative, remember, this is the same as -1 times x. A negative on its own just means it's -1 time. So the opposite of timing by -1 is to divide by -1.
Mhm.
And then if you divide both sides by -1, you end up with -x divided by -1 equals 6 divided by -1, which is just -6. Okay, so 2 common problems seen. People forget that it's a -2 before they remove the brackets. And the second one, when they get that -x, then they get confused and they're not too sure what they need to do. Or the other thing I've seen sometimes, people tend to now switch the 6 into a 1/6. Okay, so you just adopt the same approach that you would. To get rid of a -1, I need to divide by -1. And 6 divided by 1 is 6, but because it's -1, it's -6. Okay, so don't always think you've got to have a fraction. But remember, 6 is a fraction. The fraction for 6 is 6/1. Okay, so those are called rational numbers because we can write them as a fraction. So if you think like that, maybe you're going to stop switching that 6 into a 1/6. Okay, so couple of mistakes sometimes done with that kind of questions. Next one. Whenever I've got this to solve, the first thing that comes to my head is I've got to solve a trig equation. I'm going to use this. I should be seen in every paper. This CAST, CAST. In here, I've got a positive angle between 0 and 90. In here's 180 minus the angle, 180 plus the angle, 360 minus the angle. So you can do it there, or you could do it here if you would rather do it here. Okay, so some people just do it like that. Okay, but at least you should have that. So if this is alpha, that is 360 minus alpha here. And the 180 take away and the 180 plus. So that's the first thing you should do. And then because you've got to be solving a trig equation, you just treat now sine x as if it was a big X, for example. So to get your first mark, you would need to solve this first. So I've got a time 4. What's the opposite of timing by 4?
Right.
So
By 4.
I'm gonna divide by 4 both sides. And I've got 2 even numbers. I can divide the top by 2 and the bottom by 2, which just gives me a half. Okay.
Yep.
So that would give you your first mark. So if this is 3 marks, you've got your first marks given there by just solving this. Okay. Now, how do we get the other marks? It's positive. So I'm going to look, where have I got sine positive? I've got sine positive in that first quadrant.
And it's sine.
And where it says S. So that means if I find the angle here, that's going to be one of my solutions. That's your second mark. And then the next one is to just do 180, take away the angle, and that would give you your third mark. Okay, so the opposite of sine x is inverse sine, which is on your calculator sine minus 1. So you do shift sine, a half, that would give you x. So shift sine of a half. So there should be like a wee line there, even if you can't see. Shift sine of a half is 30. Okay. Then once you've got your shift sine, we said that the second one was at 180 take away 30, because that's where S is positive, right?
Mhm.
Oops. 180 take away 180 take away 30 is just 150. And your two answers, you can write them like that if you want, or you can just leave it like that. Your two answers are x equal 30 degree and x equal 150 degree. Now, before you go, are these two answers within where x should be? You just quickly check. Yeah. So they've asked me to give the answer between 0 and 360. And that's you. You've got both answers there, and they're both within 0 and 360. Okay, so it's important to check that quickly. And I'll let you know why, because there was another question later on where I've made a mistake myself. I didn't really look. Okay. So any question with the trig question there? 3 marks. Okay, so I told you leave 6 for the moment. You don't need to do it just now. Should be able to do it in a couple of weeks' time once we looked at standard deviation. We're going to look at 7. Factorize fully. So whenever I see this question, factorize fully, 3 things about when you do factorizing. You're going to look for highest common factors. Okay. So that is given by you looking at those numbers. I've got a 2 and a 32. They're both evens. That means they're both in the 2 time table. So the first thing you should be trying to think of doing is I'm gonna have to do 2 outside open bracket x squared minus 16. Okay, and that is just x squared minus 4 squared, and you may be able to remember that, or x squared minus 4 squared, that's differences of 2 squares. Okay, but imagine if you couldn't remember differences of 2 squares. Remember I told you there was my foolproof method would be to use MAM. Can I factorize s squared minus 16 using MAM? Yes.
Yeah.
X minus 4 plus.
Yeah, basically I'm looking for 2 numbers. When I add them, I get 0. So they must be opposite numbers. And then when I time them, I get 16. So my solution should be minus 4 and plus 4. So even if you couldn't remember differences of 2 square, you should be able to factorize by knowing that this is an ax square plus bx plus c, where b equals 0. Okay, and the 2 answers, if you time 2 numbers, that would give you negative 16 is a negative 4 and a positive 4, especially if you've got to add them to get to 0. Okay. So next one is the type of question sometimes you see people struggling because they haven't looked at it for a while, but again, you've got more than one way to get this. So you can look at how much the value of the house is going to increase every year, and you do it for 3 years. But you have to remember that for the following year, you need to use the value of the house at the end of the first year, then the value at the end of the second. Or if you remember, you can just use a quick formula which tells us that it's £74,000 time 1 plus 4.5%, but you need to write 4.5% as a 4.5 divided by 100. And 9 times out of 10, these questions are calculator questions. You just need to, whatever you see there, 74,000, you just use your calculator and type exactly what's there. 74,000 time open bracket 1 plus, use your fraction there, 4.5, and then over 100, close bracket, and you put that to the power of, because it's for 3 years, 3. So if you type that, you've got your answer there. Okay. So now you've noticed I put my first answer with ... because what I'm looking here is a value in terms of money. So even if they don't tell you to give your answer to the closest to 2 decimal places, whenever you're going to deal with money, it's to the closest pennies basically.
Yep.
And because it's 3 after the 9, that means you just what we call a round down, or you just leave the 29 the way it is. So to get your final mark, you need to give it into money like this. Okay.
Yep.
So that's how you would do this one. Now here, I've got a triangle. Triangle has got 3 sides. The first question is it right angled? So now what you need to look at into here is, the good thing is sometimes it's probably not a bad thing to say, okay, I'm going to try and draw this. So get the habit of sometime drawing, it might help you. So I've got the longest side, we always said is always opposite the right angle, yeah. So 83. So that would be 79, for example, and that would be 19. Okay. So 9 is asking us the converse of Pythagoras. And the converse of Pythagoras, in order to get a right angle triangle, if I square the hypotenuse, I get a value, 6889. And if I square each of these shorter side individually and I add them, for a right angle triangle, those two should match, yeah. And if they don't, that means I don't have a right angle triangle. So that would give you your first mark. To get your second mark, you need to make the statement. Okay, so what they mean by that is you need to say that 83 squared is different than 19 plus 17 both squared. By the converse of Pythagoras, the triangle is not right angle. But to be honest, even if you can't remember that word, the converse of Pythagoras, if you just put since 6889 is different than 6602, this is not a right angle triangle. That would have been enough. Okay, so you don't need to learn that word by heart.
See, I just wrote this is not a right angle triangle.
Or not
That's
a rat. I wrote
Okay.
that out.
Yeah.
But then some markers can be a bit, I don't know, picky if what you're kind of writing down.
But you need to put a statement
Yeah,
that shows that you've got these two not matching, right?
Mm-hmm.
That 6889 is different than 6602, or 83 square is different than 19 square plus 79 square. And because of that, this is not a right angle. Whereas if they were equal, you would say, since they're equal, I have a right angle triangle. Okay.
Yeah.
Next one, remember I told you you use your formula sheet. First thing, if I'm asked to find the roots, okay, no, you don't need the formula sheets here, because if you ask to find the roots, basically what they're asking us to solve is x squared minus x. That's what they ask us to solve, x squared minus x minus 6 equals 0. Okay, find the roots. So you're going to say, okay, I'm going to use MAM here. I need two numbers. If I time them, I get -6. And if I add them, I get -1. Okay, so usually to be 1, when I add them, the two numbers needs to be close to each other, right? Because you may say, oh, can I try 6 and 1? 6 take away 1 will give you 5, so it's going to be not good. To get a 1 or a -1, they need to be close. So the next one would be 3 and 2. Okay. So 3 and 2 would work. Which one is the negative? Which one is the positive? Because you've got a negative before the x, then you need to do -3 plus 2 to get a -1. That usually tells you which one is the negative. Okay, so the roots are going to be x minus 3 equals 0 or x equals 3, and x plus 2 equals 0 or x equals -2. So that's your roots. Yeah?
Yep.
So MAM doesn't give you the roots, but MAM gives you how to, so to get the roots, you need to solve basically x minus 3 equals 0. And that is x equals 3. And x plus 2 equals 0, which give us x equal -2. Remember when we did MAM here, we got a equal -3 and b equal 2. Those are not your roots. Those are what is a here and what is b here. Okay, so that's a, x plus a times x plus b. Okay, so that's a common thing that we see, people missing the mark because they just say, oh, x equal -3 and x equal 2. But if I were you and you get a couple of minutes before you finish, you take that 3, you plug it back in. 3 square is 9. 9 minus 3 is 6. 6 minus 6 is 0. So then that means +3 works. Whereas if you had -3, you would put -3 times -3, that's 9. But -3 become +3. So 9 plus 3 would become 12. 12 minus 6 is not 0. Okay, so that would be a quick way to check it. Yeah. Next question. Evaluate. So this is a BODMAS type question. Yeah. So the first thing I do whenever I get a BODMAS question, I just put the brackets for my own sanity. So I know what I'm going to do first. And BODMAS tells me that multiply or divide, the DNM, are done before any add or subtract. So that's why I put my brackets. That forces me to do this first. Okay, so this would be a non-calculator question. So you need to train yourself on being able to do 8.3 times 40. But don't be too, don't be frightened by this, because you can change a 40 in a 4 times 10. Usually what put people off is the decimals. So if I can get rid of that decimal, I can by timing it by 10, then half your work is done, because it's easier to time 83 by 4 than 8.3 times 40, right? Yeah.
Yeah.
And same here. If you don't like to do upstairs, downstairs type work, if you don't like this, you don't have to do that. Remember, you've been taught that 83 is 80 plus 3. Yeah. And if you time that by 4, you know that math told you that you can do 4 times 80 plus 4 times 3. Now that becomes much easier.
It's 320 plus
320 plus 12, and you've got less chance to make a mistake now, because 20 plus 12 is 32, so 332. So you don't need to do a lot of math to get the right answer.
Yeah, just done 83 times 4, and then got that's 332, and then just added that on to 14.2 separate.
Yeah. Now that I've got my 332, I just need to add 14.2. And you can do that upstairs, downstairs if you want.
Yeah, 346 times 20.
Yeah, as long as you place it correctly. That's like 0.0. Okay. Now you can do 6, 4, and 3. Okay, so have you noticed these are primary school type work? That's what math is. It's a subject where you need your skills that you've learned from a very long day back to bringing it in. But if you can find quick ways to solve it for you. Okay, but again, if you don't like decimals, you can just say 332 plus 14 plus 0.2, which is 346.2. Okay. So this is all to do with practicing these. If you think you might struggle, because you do get questions like this during a non-calculator. So it's not so much, do you remember BODMAS, obviously, but it's more to do with you being able to manipulate numbers.
Yeah.
So next one, find the equation of a straight line. And I've been told it passed through 2 points. First thing first, I'm going to write down what is x1, what is y1, what is x2, what is y2. Yeah. So as long as you identify that, that's the start. M is y2 minus y1 divided by x2 minus x1. and you can use y minus b equal mx minus a. Okay, so maybe what I would do as well is I would decide which one is a, which one is b. So you can pick the first one, you can pick the second one, it's up to you. So m first, 9 minus 3, that becomes plus 3. 2 minus 2, oh, I'm stuck here. Because if you put that into your calculator, you'll find out that we can't divide by 0. So it's good that you've seen that one. Because what is this telling us now? We do have a straight line, but we can't write it with an m. M doesn't exist. Okay, so what's happening here? I've got x1 equal 2, x2 equal 2. So no matter what y is, x is always equal to 2. And this line is called the x equal 2 line. Okay. So if you had a blank and you get something like this and you're not too sure what to do, you could just go on the side of your paper and just say, you know what, I'm going to try and draw here. So I'm going to draw, this is y, this is x. So for x equal 2, so this is 1, 2, I've got for x equal 2, y equal negative 3. So minus 1, minus 2, minus 3. So that's my first point, right? And for y equal 9, 1, 2, 3, 4, 5, 6, 7, 9, I've got x equal 2. So it's not that one, it's x equal 2. So if you were to draw that line on the side of your paper, you would notice straight away this is a line that crosses, it's a vertical line. So any vertical lines are in the format x equal something, the number 2 there. Whereas if you had a horizontal line, it would be the y equal the number there, whatever number you're cutting there, the c. Horizontal line m equals 0. Vertical line m is undefined, but x is always the same value. Okay. So this is Nat4 straight lines, but you need to be able to get back onto it. Okay.
Mhm.
So it's probably one of the hardest question, I would say, on the first 25 questions. Yeah.
Yeah, I would say so. So far.
Next, I've got to simplify surds. So when it comes to surds, the first thing you need to try and do is find out square numbers associated with those numbers inside there. So I've got a 12. Can I change the 12 into a square number time another number?
2.
So 2
root
times, so 2
3.
times 6, yeah. So you,
Root
yeah,
4 times root 3,
yeah.
and then 2 root 3. Because
So
4 is a square number.
4, yeah. So 4 times 3 would be that, and then that becomes 2 root 3. And then we need to do the same for 60. So we need to find 60 is 4 times 15, for example. And then that would be 2 root 15. Okay. So now 2 root 3 and 2 root 15, that would be root 3 over root 3 times root 5. And then you can simplify the root 3 divided by root 3 is just 1 over root 5. So they've not asked us to give your answer with the by rationalizing the denominator by making it something different than a third. So you can just leave it 1 root 5. But you can write root 5 over 5 if you want, but you're not going to get an extra mark. So if you've got a question where it's just simplify and not asking you to give your answer with a rational denominator, you just leave it like that. Okay. So now you might say, what can I do if I can't see that 4 times 15, right? So what you could have done, if you couldn't see the 4 times 15, you could have decided to say 60 is 2 times 30, which is 2 times 2 times 15. That might have helped. 2 times 2 times 15. So if you're stuck, same for that 12. If you can't say it's 4 times 3, you can say it's 2 times 6. But 6 is again 2 times 3. Then that might help as well. Okay, so don't get bogged down if you think, oh, I don't see what is the square number associated with that number. No, I've got 2 even numbers, can I half them? Yeah. I got another even number, can I half it again? And then you'll get your answer eventually. Okay. Yeah. So you might say to me, if I hadn't seen that root 4 is 2, for example, you can still write root 4 times root 3. And at the bottom, you would have root 4 times root, what was it, 15?
Mhm.
So you could have just gone like this first, root 3 over root 15. But root 3 over root 15 is the same as root 3 over 15. And now you've got to simplify a fraction. 3 over 15 is 1 over 5. And that is just root 1 over root 5, which is just 1 over root 5. So there's more than one way to get there, but you need to get to a point where you can't simplify anymore. Okay. So the next question would be changing the subject. So I'm going to have to isolate b on one side. So because I've got negative root b, if you want, you can move negative root b on the other side and have L on that side. So there's a school of thought where people just go, well, that is root b on that side, 3a minus L. But the opposite of rooting is taking the square, is squaring. So your final answer should be b is just 3a minus L square, because root b times root b is just b. Okay.
Yep.
Okay, so question number 15. The graph shows y equal 5 sine x minus 4. Find p and q. So here I've got 5 sine x minus 4. You might think, how am I going to get these? P and Q, not R. So can I solve y equal 5 sine x minus 4? Yeah. So what you could do is you can decide at Q, y equal 0. Can you solve 5 sine x minus 4 equals 0? Why not? Five sine x minus 4 equals 0, which just means sine x, 5 sine x equal 4, or sine x equal 4 over 5. So at y equals 0, x equal inverse sine 4/5. You type that in your calculator, and that would give you 53.1 degree, 1 decimal place. Now you might think, what about, where would R be? Remember when we do cast, sine x would get 2 answers. That would be the second answer. 180 take away 53.1 would give you R. But that's not the question they've asked us. So we're not going to answer a question that doesn't give us any mark. How do we find P? So remember, sine x is at its maximum when sine x equal 1. Yeah?
Yeah.
So how do you solve sine x equal 1? You just say 5 times 1 minus 4. What's 5 times 1 minus 4?
1.
1. So when sine x equal 1, so now x is inverse sine 1, which is 90 degree. So now I've got all my points. P is 90 and 1, whereas Q is 53.1 and 0. So you could see that this trig question was a bit tricky because you had to decide at point Q, what do I know? At Q, I know that y equals 0. And at P, sine x equal 1 would be your answer for P. So P would have been probably the hardest of the two. Okay. So Q is one of the x-intercept, but P is when sine x is at its max. And the sine signal is max when it reaches 1. Okay. So I'm going to pause the recording just now, or I'm going to